So now we're live. There's a couple things I wanted to update you guys on just quickly before we get going.
Yeah.
Still. There you go. Is anybody else in the room connected? No. The other thing you could do is just plug in a set of headphones and just don't listen. But is that better? Okay. So one of the things that is coming in, I just merged this. Rowan worked on the examples. I'm just going to share my screen so you guys can see this. So we now have an example gallery. So if you go to, it's on the dev docs. Once we get this into master, that'll be live on like the normal docs. So I'm just gonna make sure my screen is the one. Share. Cool. So if you go to examples, now we have a beautiful gallery of SimPEG examples. So that's now deploying and good to go. So thank Rowan for putting the time in to make that happen. So now you can download them all as like a zip or notebooks. And when you look at each individual one, there's again both options, which is pretty slick.
Cool.
Cool. So
is it automatically generated? Like, so if we update, for instance, like the example blah.py, then that'll automatically generate this form.
Yeah, so what you have to do if you go into SimPEG is the examples have moved, so they're now here. Let me see that again. So the examples are sitting here, and so they're broken down into like basic, mesh, maps, all of these guys. So you just create an example wherever it's appropriate, and that's all you have to do. So there's no more running of that init file or anything like that. You just create an example.
Cool.
Cool. So, John and Seogi, I know you guys both have things to share. Who wants to go first?
Okay with that.
Dom, do you want to take the lead here first?
Sorry guys, my connection. I don't know why, but it's really lagging. I'm not gonna say anything. I'm just gonna try to hang on to you.
Okay, no problem. Well then, Seogi, you're up.
Yeah, so I got a couple of things.
Do you want the cord, or do you want to just share your screen and I can display it?
Yes, I'll just share this. Right. So just share the screen?
Yep.
Yeah, so I got some updates for grounded source for time domain EM package. So like previously we didn't have initial condition is implemented for grounded source. So now your initial condition is what's that? Depend upon the conductivity model. So you need to take the derivative and then you need to put that into like your code. So I did it. It hasn't merged yet. It's in the EM line source branch. But basically you can, so for instance, if you want to use that line source, so...
Sorry, we're not seeing Seogi's screen.
If you click on
you need to click on his feed. It doesn't pop up automatically because he isn't sharing his mic. So I don't know if that gets recorded into the video.
Yeah, it does.
Okay.
Can you see it now, John?
Oh, do I need to
Yes,
turn
thank
on?
you guys.
You're good. That's great.
Okay. Yeah, so there's like source is equal to EM this line. It's basically like, that's what you need to do. So line current, and then you pass the current path. So here, like, you can put pretty general path, like, so if you have a pretty well-defined Y-line path that can handle like those paths. So it's integrate over to the edges. So that's possible.
So this is for EB formulation.
Yeah, it's only work for EB formulation. For HJ, we need to rewrite that code. And it's only work for tensor mesh, so it's not going to work for octave mesh.
Okay.
Okay, then, right, so I ran inversion. So it's a pretty small example. I think the mesh size about 150,000. And then I got 10 time channels, I guess. Then so fit the data, so you can recover. So this is the true model.
So a quick question, why wouldn't it work for octree? There's a set of assumptions?
Yeah, well, like, well, I think there's the only things, like, if I can find all this, like, a corresponding cells where the wire path goes.
Yeah.
Because I generate the sort of interpolation kind of basis and then integrate over through that path.
Right.
So I need some functionality to find, okay, I have this path and that path, and I need to know which cells I'm passing through.
Okay, so there's a chance that, like, if you were changing cell settings, we would just, like, straight out miss.
Right, because like I assumed, like, when to write it, but I assumed the tensor mesh.
Okay.
So yeah, but it, like, if you got some utility codes, I think it's not like a major change to write that, but yeah. So as long as we got the same functionality, then we might good to go. But like, yeah, just putting that in, like that's what I meant. Like, if you put just the octave mesh and then run the code, it may not work.
Right. Fair enough.
But if you had an octree mesh where the core center of it was the same as like the core of a tensor mesh, do you think you could like define it on the tensor mesh and then run it on the octree mesh if all of the edges and stuff were in the same location? They didn't change at all?
Yeah, but still, then you need some sort of
I guess
mapping.
the indexing.
You still need some mapping code where, like, because it's all about like indices, like values and numbers on the edges. So if you can find the corresponding edges in the octree mesh, you're good to go. But I wouldn't do it. I would just generate in the like 3D octree mesh. So I would rewrite the code. But but I think it's not a huge deal, I guess. So you can recover conductors and resistors. So here I'm using H3DTB to generate the for modeling data, and then it's like compared with that UVC code, and it matches pretty well, and I can recover the model as well. So
nice.
Can recover both conductors and resistors fairly nicely. Yes, I didn't do any fancy things. I think I just put the default inversion parameters. So it's about like 10 iterations, I guess.
Cool.
So that's basically working. So meaning, like, if you have a great grounded source data, you can run the inversion.
Yeah.
So that works for both general waveform and the step-up waveform now. So it's pretty general now. I think that's pretty good. I got the same example with the DC example. You can get better result with TDEM, which is sort of expected.
And this is the one where you had like a horseshoe wire?
Yes. So I think the wire path. I think I sent an image before. I think I don't have enough, but the wire path is here, like this.
Okay.
sort of small.
When you kind of have grading array data
Yeah,
in the middle.
yeah. So sort of my favorite, simple, small example. Still works. But for DC, you don't have depth resolution in this case, so you need to assign the depth weighting to put things in there.
Yeah.
So that's sort of update in the time domain. Yeah. Other things what I'm working on is like a processing problem. So for instance, like say, I'm setting up it's a time decaying curve. So you have a whole bunch of time decaying curve in airborne data, for instance.
Yeah.
And I want to fit that each stations, but I want to kind of put some sort of constraint on the space.
So sorry, you want to fit it in terms of.
It's a single decay curve.
Okay.
It's fitting
So you want to fit an exponential.
Yes.
Okay.
Basically, I'm fitting the exponential.
Yeah.
But the that slope, I want to put some constraint in space.
Okay.
So you can set up an inverse problem each station separately.
Yeah.
But you can set up an inverse problem together.
Okay.
So and you can put some regularization. So it's like a kind of sort of different use of what, like how you can use the SimPEG inversion class. So basically, like this is the waveform that I'm putting in for V10, and so it's basically the same, but you input full airborne data. So I think it's a Mount Milligan example, and you can run the exact inversion, and can fit all the curve.
Yeah.
Takes a while.
So you're fitting all of the data.
Yeah.
Okay.
Yeah. So and then at the end of the day, you can get tau map and the time domain. So you can get
cool.
like a tau map as well. But you have a multiple tau. It's a little bit different, but anyway, you can at the end result you can get the tau map, but you can get some sort of proxy of uncertainties because like you're using smooth basis function to fit that. So it's simple processing code that you can simply use. So like for instance, the tau map looks like that, and then I was using I want to fit just the positive data.
Sure.
And then you can simply decouple IP as a proxy.
Yeah.
So you can recognize where your IP signals are, for instance. But it's a simple curve fitting code, but I put a smoothness constraint. So for instance, like how the code looks like, it's so that looks like that. Yeah, so I have a survey, exponential fit survey. It's fairly simple.
Yeah.
You can set. I need some a way to set an uncertainty. For my case, I had to put it in, but generally you don't need that. So basically, you just need to do eval, and then here's my problem. So you have a different kernel function that you can use, and basically here I'm generating the sensitivity matrix. So that's just once, then I don't need to update that. So it's a linear inverse problem. Yeah, so it basically looks the same. Our structure is same. So now JVAG and JTVAG.
Yeah.
It's pretty similar, but now you've got G matrix. So I think probably Dom's MAC code might be pretty similar to this, I guess. And then my line regularization, for instance, for airborne case, I have each line. So I can put a smoothness constraint in line.
Yeah.
So I want to make it smooth in line. So my those inversion parameter will be smooth. So it's basically all same ideas, but much simpler problem. So yeah, but you can rewrite that just this part, then you're sort of good to go.
That's really cool.
Yeah, and then there could be multiple applications. So this is a one case.
Sure.
But I could do it for DC, like a DCIP, for instance. So this is IP example. So this is my decay curve for IP. So I'm plotting all the decay curves that I have.
Yeah.
This is a dipole array. And if you look at the pseudo section, it's basically the same idea, but I'll just show you the result. So if you look at the, so this is a parent resistivity pseudo section. So that's the data.
Okay.
And then that's IP pseudo section. It's the chargeability section.
Yeah.
But like you have multiple time channels. So you can fit that and recover like tau.
So sorry, the apparent chargeability though that you're showing is a snapshot at a single time?
No, yes. No, it's an integrated value. So what they do, they integrate a certain time channel and then plot. So they have a sweep window.
Okay.
But but you have a multiple time channel. So you can actually fit that. But basically same idea. You can use exponential function or whatever, like a simple function to fit that curve and then recover some parameters. I haven't put it any smoothness constant, but you can actually grab some points, compute the gradient, and then put it in as well.
Yeah.
But at the end of the day, what you can get out of it is like, so you can get out of like a multiple parameters from that curve. So this is a C value. This is time constant. So time constant is interesting because like you got some trend. Right? But at the end, like this is sort of what the plot you can get. It's a cross plot. Is like, so this is tau. The x-axis is tau, and y-axis is apparent chargeability. You can see the trend, but you can drape over the apparent resistivity, meaning like a active region where you have a small tau and small chargeability.
Yeah.
But the high resistivity, this region has and the greater chargeability. So you can sort of can do some sort of classification, but it's just all in data space. But it's a simple data fitting algorithm that you can use it. So it's still the thing that I was thinking, because we don't quite have any data structures.
Yeah.
So that's probably what at least just a table structure that if you can have some simple data structure that we can consistently use. That's probably good, because how I'm doing is I'm using just a dictionary at this point, but something like that.
Right.
For DC, I guess.
Huh.
That's where I am.
And where is this? The code you're using to run this? Is this on?
Oh, it's my local branch at this point.
Yeah.
But I want to.
Is it up on GitHub though?
Yeah, it's in GitHub.
Cool.
It's called SimPEG EMIP. So this is where I'm putting most of my PhD research.
Yeah.
The main thing is the formalin code that you can put the IP effects in formalin. But there's some utility codes that simple processing code that you can fit it and recover some values. Hopefully we can merge in at one point.
Yeah.
I'm just still actively working on it, so I don't want to kind of be bothered.
No, absolutely. I'm just curious because I want to sort of see how you're thinking through the problem, and in particular, getting some ideas on the data structure and what that needs to look like.
Yeah. What I really like is this. I'm not sure how you guys using this wires and property class. So I got this all of this property. Yeah. And how I'm just way I'm putting things together is there's my wires. Okay, so this is my wires.
Yeah.
So this is a simple case. All of your variables have the same dimensions. Yeah. But depending upon how you formulate it, it could be different. So it's kind of cool. At the end of the day, you can use the same mapping to output the tau values and because you have a big long vector, so you need some matrix to extract all of your variables somehow. Yeah. So that actually supports that. I thought that's pretty cool.
Have you played around with the combo regularization at all?
No, I haven't yet. That's my next step.
Do you have a small example that like I could help you
Yes.
rewrite?
Yes.
Because that would be.
Yes. So I'm sort of rebuilding a couple of things in both in DC and like an EM code.
Yeah.
So I could have a small example.
Okay, because that would be awesome. I'd be curious to get your input on that. That's really cool, Seogi.
Yeah. So that's how I'm imagining like the kind of processing stuff. Because like at the end of the day, I think a lot of processing problem can be set as a linear inverse problem or even non-linear inverse problem.
Yeah.
Meaning like if you got certain data structures,
Yeah.
Then like we can actually basically use SimPEG framework to process the data.
Yeah.
And so use it in a little bit different way than now. So that's what I'm hoping.
What are your thoughts on developing the processing as a separate package, or if it should be within SimPEG?
I think I would just go like for instance like I would just focus on EM now.
Yeah.
And then just do it in EM package. So EM dot processing.
Yeah.
I think that's what I would, because like it's very like aligned with certain problem.
Yeah.
Having a really separate like a package is kind of I don't know. I'm not sure what's the good way. Because like and then like processing package forces you to have a data structure.
Yeah.
Then that will be helpful for in both ways, like both in processing and also in a SimPEG problems.
Yeah.
So I think it's sort of a win, I guess.
Yeah. No, I agree. I think originally we were thinking of having it separate, but it's so tied to the problem.
Yeah. So I would that
now,
like even like for MT processing, I would attach to an SEM problem.
Yeah.
So an SEM dot processing.
Yeah.
For instance, something like that.
Yeah.
That might be more. You could probably have a more general structure.
Yeah.
But in the outside, I think like EM dot processing or time domain EM dot processing, that kind of makes sense to me.
Yeah. Well, and I think like in a lot of ways, developing the same way we did with discretize, basically, it's like you develop everything in one place, and then once it's mature enough and we realize that it is a self-contained piece, then you pull it out.
Right.
But for now, like it's part of the EM problem, so.
Right.
Yeah, I think that makes a lot of sense.
Yeah.
I would be tempted to argue that different.
Okay. What are your thoughts there, Beauty?
To actually develop it outside of SimPEG.
Okay.
Because I mean it doesn't really matter where it's developed, but it should not necessarily live within SimPEG, because SimPEG is fairly focused on the modeling. And we do have a data structure within SimPEG, but it really needs to be reworked because it's very geared towards the inversion problem.
Yeah.
Or the modeling problem. So so having
I still I kind of agree with like I'm okay with where it leads, but I think we need some, because like I'm sort of thinking about how I'm using it.
Yeah.
Because like I would prefer to do like like if I'm doing say MT processing and inversion, if I could do NSEM dot processing dots blah 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 technique, that would like resonate with me.
Yeah.
But
I would.
I'm not sure. Haven't quite be in that situation. So what I'm doing like now, I'm using DC and IP in these days. So like my workflow, I had to put my data into a certain framework. It's still not. I had to generate the data frame by myself, which fits me.
Yeah.
It's basically just a table, like locations and the data and time channels. And that's just one like a workflow. I need to do processing, and then like I need to make it as invertible.
Yep.
Then invert. So I think that's just a full like a workflow, and if that can be in a one or like one shop or one package, I think that might be good to me. But like, I'm not sure like where those are leaving, but it needs to be accessible into a single framework. That's what I was thinking. For changes.
Yeah, no, I totally agree with you on that, Seogi, but I would say that we should have our kind of own or processing, and I mean data in general should almost be separate from the inversion and modeling side, because you're dealing with, even though it's you can reuse some of the techniques and in the infrastructure that we have in SimPEG, it's a very different approach, and something that you should, I mean, you should bear in mind the fact that you're going to model it or you're going to invert it later, but it's also an independent step that needs to be dealt with. Like, I would never take field data and process it and then invert it kind of in a single kind of pass. You would do the processing and you would kind of make sure that the processing of the data is up to standards or up to snuff, and then you would proceed to the inversion. Not saying that you shouldn't go back and reprocess, but these are, I don't know, two animals that live in the same zoo.
Yeah, and one of the things that I think is interesting, like from your first point, Guni, is, you know, SimPEG so far has focused a lot on the modeling. But in some ways, I mean, we built everything from the inverse problem as the primary goal. So it's a question, I guess, of scope and then also of strategy. Because in some ways, like I do like the way we developed Discretize is that we tied everything together, and then once it's mature enough, we pull it out. But I don't think there's merit to both approaches, and I'm sort of wondering if the strategy to take here to figure this out, because we're certainly not going to just resolve it today, but is to sort of lay out like what are the types of problems we want to tackle in processing, and like what Seogi's already done, just like have a list of things that have been done, and we can start to just get a feel for what this looks like, and then maybe make a next step from there.
Yeah, I also think it might be easier to get people involved in processing.
That's fair.
Without kind of getting them into the overhead of SimPEG, of the modeling. I mean, people probably will want to do both, but it might be kind of, it's less daunting to get into one thing. When it's kind of, it's separate, but it's kind of like that SimPEG sphere. It's all connected, but it's still like Discretize. Like it's, but I think just it is such a related topic that I personally think it would be better to kind of keep it separate. I've been thinking even with the NSEM data class whether it should be, because then you're also not limiting yourself to only SimPEG.
Right.
But I mean, it's obviously optimized for SimPEG, but it's just kind of question how, and then I guess with MTPy, for example, it's kind of how are we going to interface to something that already is there?
That's fair.
So, I mean, I think it kind of connects to a bigger picture, but I think we should. But at the end of the day, it doesn't really matter where we develop and how we do it initially, but we just need to be mindful of where we're going with it.
That's a very good point.
What you got there, Seogi? What is this?
Pardon me? Oh, sorry. This is 2D inversion. I got some field data. So what I was doing, I did the 2D inversion first. So I got 4 lines of dipole data, and then do the 2D inversions, and then like did some QC that I could fit the data, recover the model. So I play with some weighting and stuff. But yeah, I also did the 3D inversion. So this is my model. I got pretty poor topography, so but I recovered like some resistor and conductor. So
Nice.
yeah, so yeah, it was just like it was actually my first kind of like a little serious 3D inversion using SimPEG DC code. So yeah, but yeah, it seems like it works pretty well. So I was impressed. I didn't know that actually works. But what might be good to develop by like because I did it just by myself, but the kind of a good kind of survey class where you can extract 2D lines and kind of run the 2D inversions and like, or you can run 3D inversion, or you can easily visualize that types of things. So I think that's not hard, but like just need to put it together. But we got all the pieces. Like we got like we can do break over to the topography of the electrodes and those kind of functionality. We've already got the codes, but it just need to put it together as a good kind of workflow.
Yeah.
Or at least the functions that we can run through the SimPEG classes, I think. So yeah.
Hey, Seogi, you sent me a notebook. Is that one? I can't find it. Do you mind resend it to me?
Yeah, I'll send you. Right. Yeah, I think. Yeah, I was using some of your utility stuff. So. Yeah. Right. You did it. Right. That's true. That's cool. So I kind of okay. So here's my question then: do we need to put like those functionality in the survey class? Is that what we need to do, or what's
Sorry, which functionality?
For instance, okay, I got full 3D data set.
Yeah.
Okay, I import that somehow.
Yeah.
And then I put that into a SimPEG survey class.
Yeah.
Okay, but I got all the line indices. So for all of my electrode like data, I got line indices. So I can easily find which line is it.
Yeah.
So I can generate this 2D survey in the survey, like a 3D survey class.
Yeah.
So if you want, if you can have some functionality that like takes the 3D survey and outputs that 2D line.
Yeah.
I think that's kind of simple and probably even like visualize it.
In some ways, I would potentially like to see it a level lower, is that we can basically bring in the data and then be able to, so on the data class, be able to generate a 3D survey or grab a line and generate a 2D survey. So actually do it from the data class, and then surveys can be generated on top of that.
Yeah, okay. So currently how our like a visualization, for instance, this guy works.
Yes.
It's like we take the, for instance, this visualization, we take the survey class to generate the pseudo section.
Yeah.
Which is okay, but that's a little bit different what you mentioned, Izzy. So
Yeah, that's fair.
yeah, wasn't sure what is the best way.
Yeah, I think like rethinking the survey and data class needs to happen soon. Because one of the things I encountered with, I got an email from Alini, who was a student with Yaga, and she's working on generating time domain and wants to forward model with both conductivity and permeability. And so the thing she was doing, which like makes sense as a first pass, is that she was generating all of the source locations and then all of the receiver locations and defining one source, which is of course not how we do it. We generate, each source has only a single location. But we had no error handling to catch that. And so she generated like a vector of source locations and a vector of receiver locations. And so the way, we just need like more structure around helping people set up surveys, I guess is my only point. Is because for generating that airborne survey, you actually just had to generate a source with a single receiver for every location, rather than doing the lists. But that's not really, it's not really transparent from the outside.
Yeah.
I mean, I think we also need to.
Yeah, I thought that's easy, but maybe.
It is. Like, it's not hard once you know what to do.
Okay.
But if you're sort of, if this is your first encounter with SimPEG, it's not
Right.
immediately obvious.
That's true.
Sorry, Kimi, you were gonna say something?
Yeah, I was just gonna comment on that. That I totally agree with this. I guess agenda of kind of reformatting or revamping the survey receiver data interface. But we also need to think about the implementation in terms of what is the data, and it should be flexible. But I mean, we need to be careful how we do the inverse problem and how we need things to be set up.
Yeah.
And then we need to have something else that people can kind of more easily take a data file or a data survey or like their work and make something happen and kind of on a higher level without having necessarily to dive into that. We call it receivers with an S, meaning that it can have multiple locations versus a source is a singular and should only have one location. So it just, I mean, these are details that if you just have data and you want to work with it are just annoying to have to go through. You will probably want to do it after you test out your data, but it's just, it's an inconvenient hurdle to have to jump right from the get-go.
That's fair.
And I mean, same with the data structure. I mean, the data structure is, because it's referenced as a source, like you reference it with a source receiver pair.
Yeah.
And I mean, for MT, that makes no sense. That is just not how you would think of your data.
That's fair.
You would think of it, I mean, you think of it as a station. So it contain all the, so it's kind of location based more than. So it's kind of just having flexibility. And I think, I mean, we can definitely do better on the receiver source implementation, but I think the data needs to be, our data classes need to be kind of a good gateway for people to get into it at a higher level.
Yeah.
And kind of build the read-in functions that are needed to get data in. Like it's such a nice place for people to start contributing.
Very true.
And it's a very difficult place for us to start trying to implement something because we're not used to working with all the data.
Right. Live in the synthetic world.
Yeah, a little bit. So
That's fair.
So
Cool.
yeah, those are my 2 cents on that. But I think kind of like we've talked about, like the location, kind of somehow being able to index the locations as well, because I mean, in the current format, we're storing the I guess the projection matrices for every single source receiver compo that we have, and they're like repeated. I mean, in the MT class, I mean, if I do it, even when I do a synthetic, I mean, I'm repeating it 8 times for each source. So, and I mean, it's also a question whether we want to actually just think about, I mean, constructing some sort of a sparse matrix that is just stored in the background that would make the projection a lot faster instead of forming it with a for loop. Because I mean, it's not the bottleneck in the code, in the MT code, for example. But I mean, it still takes me, I mean, 30 seconds to project a really big survey. Seconds that I feel that
It's unnecessary.
my gut feeling is that we should be able to do it in a lot less time.
Well, sometimes I do cheat. So you can make a same receiver class and then pass it through all the sources.
Yeah.
But at the end of the day, you can assign the infinite empty.inf to your uncertainty. Then in that way, like you're using it's in that inversion, but like impact in your inversion is 0. So like if you think about if your uncertainty is infinite, it's actually 0, right? If you're
Sorry, what do you achieve by doing this?
But you only generate one P matrix. Or like even if you have 100 sources, and then you're not like looping over for different, you're not generating different receiver class. So you can find all the unique, receiver locations, generate one receiver class, and then pass it over to all the sources.
Okay.
Right. At the end of the day, you just need to know which is not included in that sources. So you need to know that indices, but you can assign that infinite to uncertainty. So, well, I think that's actually how the UBC code works. So they find unique receiver locations and then generate one P matrix for projection or evaluation. Then they generate like a weighting matrix, and then they put the like a some infinite value or like a zeros on the diagonal. So in that way, like you just need to generate one P matrix for but yeah, we can still do it. Like, but like, yeah, I don't know, I'm not sure which. I think we at one point we had a discussion about this, but I think we choose a different way. But still, we could do the exactly same thing even in the current structure. So, it depends.
Okay.
But the receiver class is pretty cool. So you can, even if you generate one receiver class, you can actually pass it over to multiple translators.
Right.
So yeah, that doesn't like block you to do different things.
Yeah.
So you don't need to generate the receiver class every time.
Right. Yeah.
Yeah, I mean, it's just worth exploring. I think that's something that is very worth exploring and kind of consider more seriously.
Yeah, absolutely. So we've only got a couple more minutes here. I wanted to just quickly go through, there's a few pull requests on the go and just like quickly chat about strategy for getting things in. So I'm just gonna share my screen. Okay, so the docs are now in, so that should fix deployment issues that we were running into there. So there's a few different, the next one I think to go in is going to be the objective functions. So I'd like to get that in hopefully like by the end of the week, because then Dom, that'll allow like me to do a sane pull request review on the mag amplitude one, because they are sort of intermingled. And so we can jump in and like start getting that ready to go. So I'm going to see if Rowan has a chance to take a look at this. Dom, were there any concerns you wanted to bring up or like thoughts on implementation that you think should be given a second pass before we bring this in?
Well, there's the issue of having two levels of regularization objects, right? So we have like either a combo or just a, sorry, I forgot the names. There's a combo and what's the other one?
Like a base objective function?
Yeah. So, and that's where I added a bunch of stuff on my PR to be able to deal with those. It depends if you want to do it now or we just do it when we merge mag amplitude.
Okay. I'm wondering actually if the thing to do is to generate, to switch the base of your pull request to the ref objective functions. And then that way, like, I can sort of, if you can point out an example of where you're doing that, that's something that we can try and fix before we bring it into dev.
Okay, so moving, yeah, okay, I see. So I'm moving to PR2 inside your branch, yeah.
Yeah, so it should be like just as, let's see. All you should have to do is edit and then just change the base to ref objective function. And then if you can just in the files changed, if you can just leave a couple comments of like, hey, Lindsay, this is where the objective function class inheritance is messing with me. That would be very helpful.
Yeah, sounds good.
Cool.
I can try to do that.
And then I know both Seogi and Qtney have pull requests onto EM dev. Do you guys want, how quickly do you want to try and push on those? Is there stuff you still want to do?
Yeah. I'll do it in this week. I don't have that many things to share.
Okay, cool.
I'll go through your comments and make sure.
Hey, Gwynny, on natural source, for some reason I had to look at the 1D inversion.
Yeah.
Doesn't look like the regularization is doing anything. Parameters and pretty much always the same convergence, always the same result. What's happening with that?
I honestly don't know. It's one of those things that I implemented kind of when I wrote the code, and I haven't really looked at it very much. So I'd have to have a decent look at the 1D problem. I remember when I implemented it, it had something to do with the active implementation. But I mean, that was before we had like the active in the objective. So I'll admit that I have to look at the 1D example a little bit better. But that is part of the work I did. I've re-implemented the 3D forward problem. So that is what I'm pulling on or trying to push down to EM dev, among other things.
Okay.
So I'm really trying to kind of just clean up some of my workspace to just organize, because I had like 7 different branches on my computer that I've had to kind of merge into one another to get things to work. So I spent some time yesterday cleaning that. But they're always falling on some doc don't understand.
Okay.
So I made a comment on the EM merge branch.
Cool.
But there I'm taking the EM branch and merging it back into natural source EM before I then merge that into the EM branch. So it's one of those circular.
Okay. If you ping me when you like want somebody to jump in, I'd be happy to. And like, because if you can resolve, or I guess there's the Travis fail, and that's because of the docs, and then there's some conflicts.
Yeah, so I think I've fixed the conflicts, and I am now just rerunning some of trying to rerun the tests.
Okay.
Yeah, so hopefully, once it passes, but I'll ping you if it fails on the same error. It's something about not finding a package.
Okay.
I don't know.
Hopefully fix that on the most recent exam or the most recent docs deploy, but it quite possibly not. So.
Yeah. But yeah. So in terms of natural source, the state of the code, I mean, I have an issue going, kind of a general issue of development of the natural source code. So some of the things on this pull request are things that I've kind of chipped off or ticked off that list.
Perfect.
So,
cool.
And for me, it's
I'm
just.
Sorry,
Yep.
Yeah, I gotta run, but you guys feel free to keep chatting if you want to.
Thanks, NZ.
Yeah,
We'll see you later.
Guys. See you later. Take care.
Hey, Seogi, send me a notebook. Okay, bye.
Cheers.
See ya.